I am Anil Kumar. Welcome to Basic Skills which are required to understand mathematics. In numeration, we'll take up 10 examples to review these skills. Let's begin with question number 1. We need to evaluate each one of them. You can always pause the video, answer, and then look into my suggestions. 1a is 8 minus 3 times 2. Now in this, if you do 8 minus 3 first, you'll make a mistake. We have to apply the rules of order of operation, and therefore we should be first doing the multiplication part, right? That is 3 times 2. So we get this as equal to 8 minus 3 times 2 is 6, right? So we get 6. Now 8 minus 6 is 2. So that becomes your answer for the given question, right? So order of operation is important to understand. In B, we are multiplying minus 7 with 7 times minus 1 to the power of 7. Now here, this exponent minus 1 to the power of 7, since it is an odd number, that will be equal to minus 1, right? So we have minus 1 here for the exponent. When you multiply minus 7 with 7, 7 times 7 is 49, and then you get minus, so you get minus 49. Now when we multiply two negatives, we get positive, so we get 49 positive as our answer. C, minus 100 square. It is important to understand that square is only applicable for 100, not for minus. So the answer for that will be negative, right? Negative is not squared, only 100 is squared, right? So 100 squares will give you 100 times 100, which is 4 zeros, 10,000. Square root of fourth root of 64, right? So, well, we know the square root of 64. We could write this as square root of 64 square root is 8, right? We are looking for fourth root, right? So first I did the square root. 8 times 8 is 64. You could write this as fourth root of 8 times 8, right? I could have written 2 to the power also, right? I'm doing it in more steps than essential. Now 2 square root. Square root of 8 is what? Now you could write this as square root. So whenever it is square root, it is not necessary to write 2. It is understood as default, right? So 8 is kind of 4 times 2. And you know square root of 4 is 2. So we will write this as 2 square root 2. Is that clear to you? So fourth root of 64 is basically 2 square root 2. Now we need to evaluate absolute value of 3 minus 7 minus 5. See, absolute value of any number is always positive. 3 minus 7 is minus 4, right? Absolute value of minus 4 is going to be 4 positive, right? So we get 4 minus 5 and the answer will be minus 1. Is that clear to you? Right? Next one is kind of fractions, 12 over 3 plus 42 over 7. But you see 12 is a multiple of 3 and 42 is also a multiple of 7. So faster way to do this is first to divide 12 by 3, you get 4, right? Plus 42 divided by 7 is 6, and so we get 10 as a result. Clear? Now G is square root 8 whole square. So square root, we get 8 as such, minus square root of 121. 11 times 11 is 121. So we could write this as 8 minus 11, and that gives you minus 3. So here we'll work with fractions. We have 2, 3 over 4 minus 5 over minus 6. Now this is a mixed number. We can write this as improper fraction. 2 times 4 is 8. 8 plus 3 is 11. So we could write this as 11 over 4. Minus and minus makes it positive, right? So we get positive 5 over 6. Now it doesn't really matter whether this negative is in the denominator or in numerator, right? The fraction 5 over 6 is with a negative sign. Now to add these two fractions, we need to have a common denominator. The common denominator here is 12, right? To get 12, I have to multiply 4 by 3. So I'll also multiply 11 by 3. So we get 33. and here we have to multiply by 2. So we get 10. And adding them, we get 43 over 12. So that becomes our answer, and this answer is in improper fraction. So at times, you may be required to convert this to the mixed number as given in the question, right? So let's do that. Now 4 times 3 is 36, right? So dividing 43 by 12, we get 3 as 36. And when you take away 36 from here, 13 minus 6 is 7. We get 37 over 12 as our answer. Correct? So that is how we could actually do it. Now let's look into the last example. We have 5 minus 3 to the power of 0 over 2. Now anything to the power of 0 is always 1, right? You do get 2 to the power of 0 over 2, correct? Anything to the power of 0 is 1. So we get half as our answer. Clear? So that is how we are going to solve this particular question. Clear? So I hope these steps are absolutely clear. Let's move on and take up question number 2. If x equals to minus 3 over 2, y equals to minus 1 over 4, and z equals to square root of 2, we need to evaluate this expression. X square z square plus 4xy over 8y square minus x. So let's substitute these values and figure it out. So we have x square, right? So we have, that is minus 3 over 2 whole square. So that is x square. Now z square, which is square root of 2 whole square, right? Plus 4 times x and z, x and y. X is minus 3 over 2 and y is minus 1 over 4, correct? The denominator here is 8y square. So 8 times minus 1 over 4 whole square minus x, which is minus 3 over 2. Clear? Okay. So that is the expression which we need to figure out. Now, when you square this, you get positive number 9 over 4, right? So we get 9 over 4. Square root square will be 2, so that gets multiplied by 2. So this decimal is multiplication sign plus 2 negatives when multiplied gives you positive, right? You could actually cancel this 4 and this 4 to simplify it. So what we get here is 3 over 2 divided by, now if I square this negative becomes positive, so we get 8 times 1 over 16. Minus and minus makes it positive 3 over 2. Correct? We can also simplify this, dividing this and getting 2 here. Correct? So in the numerator, now we get 9 over 2 plus 3 over 2. In the denominator, we can cancel this. 8 times 2 is 16. So we get half plus 3 over 2. Fortunately, we have the same denominator, so we can add the numerators. So we have 9 plus 3 as 12 over 2 divided by 1 plus 3 is 4, 4 over 2. Or we could just cancel these 2's, or we could write 6 over 4, right? And then we can divide them both by 2 to write 3 over 2 as our answer. Correct? So you could have gone the other way also. From here, we could also write this as, let me use another ink. We could cancel these 2's and we could write this as 12 over 4, dividing them by, dividing 12 by 4, we get 3, right? So I did a mistake here. When I divide 12 by 2, I do get 6, but 4 divided by 2 is not 4, but 2, right? So I get 6 over 2, and which should be 3. Do you see that? So I did a mistake. So we have corrected this. So here, 4 over 2 is 2, right? And 12 over 2 is 6. 6 divided by 2 is 3. How we are going to solve this? Let's move on and take question number 3. Question here is, Junior estimates that he spends 1/4 of his day at school, 1/3 of it sleeping, and 1/6 of it on homework. What fraction of the day does he left for other activities? Now, total time we'll add what all he is spending. 1/4 at the school plus 1/3 sleeping plus 1/6, right? So that is the total time which Junior estimates that he is doing some activities. You have to have a common denominator to add. The common denominator here will be 6 times 4, which is 24. However, you could also use the denominator as 12. Let me show you a technique to find common denominator, right? So that will help you. It is something like this. We have these numbers 4, 3, and 6. We could divide them by 2, right? So there is a common factor of 2 here. This cannot be divided. Write it as such. This can be divided. So we get 3. So see, instead of 24, we get a denominator which is smaller. See how? We have 3 and 3. We can still take out 3 as a common denominator. You cannot divide 2, but you can divide these 2 3's by 3, getting 1. So we get LCM in this case, lowest common multiple, as 2 times 3 times 2, and that is equal to 12. So we could make each fraction with the same denominator as 12. You get the idea. So we get 12 as our common denominator. To make this 12, we have to multiply by 3. So we get 3 here, plus we have to multiply this by 4 and this by 2. So the numerator will be 3 plus 4 plus 2, which is equal to 7 plus 2, 9, 9 over 12. Now this can be simplified. Dividing both by 3, we can write this as 3 over 4. Is that clear to you? So that is the work, right? So total work. Now, so that is the total. Now the question here is, what fraction of the day is he left with? What fraction of the day is left for other activities? Now, 1 is the whole number. So we have to take fraction of the day left. Will be 1 minus 3 over 4, correct? So that gives you 4 minus 3 over 4, or 1/4 of the day, correct? So 1/4 of the day is left. Is that clear? So that is how we could answer this particular question. Let's take the next one. Suppose you find 2/3 of a pizza in a refrigerator, right? So we have 2/3 of pizza. You eat 1/4 of it. So you are eating 1/4 of 2/3. So see, 1/4 of 2/3. That is what you eat. What fraction of the whole pizza have you eaten, right? What fraction of the whole? Now 1/4 of 2/3 is kind of multiply 1/4 by 2 over 3. And that is equal to, you could simplify this, dividing by 2, right? So you get 2. So 1/6. So when you eat 1/4 of 2/3, you actually eat 1/6 of the whole. So you eat 1/6 of the whole pizza. Do you see that? So 1/4 of 2/3 is only 1/6. Therefore, you eat 1/6 of the whole pizza. Is that clear to you? So that is how we could answer this particular question. Question number 5. Identify as rational or irrational numbers. So we have A 0.1234 and so on, B square root of 144, C is 1.2323 and D is minus 2 over 3. Now which one of these are rational numbers? And which one of these are not rational numbers? So you need to figure this out, right? So irrational numbers, we also designate irrational numbers by Q bar, right? And rational numbers by Q. So that is a symbol for irrational and rational numbers. So if it is 0.1234, right, it just continues to go on, correct? Now in this particular case, it is non-repeating decimal, and therefore that has to be an irrational number. So this one is irrational. The number square root of 144 can actually be written as 12. And you can see this is a rational number, right? So it is a rational number. Now here we have 1.2323. 23 repeats. You could always write this as a fraction, right? So we exactly know what this number is. So this number is a rational number, right? So this number is a rational number. The number here is already given in fractions, so it is also a rational number. Correct? Now, as an added exercise, I would like you to write 1.2323 as a fraction. Okay, so let's do this. It is not asked for, but let's do it. So I'll do it on the side. So the question here, which is I'm writing at question 5b, is write 1.23, we say recurring, it repeats, as equal to a over b, right? So a over b is a rational number where b is not equal to 0. So let us say x is equal to 1.23 recurring. In that case, 100x will be equal to 123.23 recurring, correct? If I take away, then I get 99x as equal to this minus this. So what I'm doing here at this stage, let this be equation 1, this is equation 2. I am doing equation 2 minus equation 1. Is that clear to you? So when I do that, I get 99, 100 minus 1. And here, 0.23 cancel, and I get 122. Do you see that? 121 minus 1. And therefore, x is equal to 122 over 99, correct? So that becomes the x equals to value, right? Now just to verify, let's use calculator only to verify. So 122 divided by 99 actually give you in decimals 1.23 recurring. Do you see that? So this is a rational number, and that is the way of writing repeated decimal numbers as a rational number. Clear? Okay. Now let's move on to question number 6, which is simplify 2 square root 12, 10 square root 3 whole square, 5 square root 32. So let's rewrite this. We could write this as 2 square root 12. First thing is let's square this. So when you square this, 10 square becomes 100 and square root 3 square becomes 3. Here we have 5 square root 32. So as far as the numbers are concerned, we have 5 times 3, 15 times 2, 30 times 100. So the numbers are 30, 100, 3000. Now these square roots, easy way to do is we have to multiply 12 with 32, correct? Okay. So let's take it one more step. We have 3000 here outside. Now within square root, you could actually write this as, because it's a square, perfect squares, right? So we could write 12 as 4 times 3. 4 times 3 is 12, right? As far as 32 is concerned, we can write this as 16 times 2, right? So that is how we could write 32 as. Now you can see that 4 and 16 are perfect squares. So we could write this as 3000, and here 4, 2 will come out, 16, 4 will come out. So we'll have 8 outside, right? So we have times 8, and within square root we have 6. Does make sense to you, right? So basically what we have done here is we could have written this as 3000, and from 4 we get 2, from 16 we get 4, and within square root we have 3 times 2. Those are the numbers left, and that gives you the answer 3000 times 8 square root 6, correct? Now let's multiply this by 8, so we get 24,000 square root 6, and that becomes the answer for the given question, correct? So that is how we are going to answer it. Now let's move on and do question number 7. It says determine the length of longest pencil that will fit inside the pencil case with rectangular prism. 3 centimeter by 4 centimeter by 12 centimeters. Okay, so basically let us say this base is 3 and 4. Let's say this is 3 centimeters and that is 4 centimeters, right? That is the base for us. It's a prism, correct? And let us say the height of this prism is 12. I'm not making it to the scale, but okay, so let's say this is your height, which is 12, correct? So that is how we get it. Now, okay. Okay. Now the idea here is the maximum will be what length? Well, we have a side which is 3, another side which is 4, and this is 12 for us. So we have to actually find this distance from one corner to the other. So that is the maximum length which can fit in. To get that length, what we could do is first we could find the diameter of the base, I should say the diagonal of the base. Now this diagonal is at right angles, right? So we have to use, and this is also at right angles. Is that clear to you? So that should help you to find the solution. So let's label this. Let me write down this point is A, B, C, and this point as D. We'll need these points. So we can say AC square is equal to AB square plus BC square, right? So which is 3 square plus 4 square, which is 9 plus 16 or 25. So AC square is 25, right? Okay. Now in the other triangle, we need to find what is AD, right? So we have AD square now is basically AC square plus CD square. Now you can see AC square, we just calculate this as 25, and CD is 12, so it is 12 square. So let's calculate. We have 25 plus 12 is 144, and that gives you 9, and 4 and 2 is 6, 169, right? So 169 is AD square. So what is AD equals to? So AD is square root of 169, which is 13, correct? Since the units are in centimeters, it will be centimeter. So our answer here is 13 centimeters, correct? So that is how you can find the solution. I hope it makes sense. Now let's take question number 8. I'd like you to pause the video, read this question, solve, and then look into my suggestions. Question number 8. Alexandria plans to purchase a new long-distance telephone plan called the Silver Plan. Under this plan, the telephone company determines the monthly cost using the following charges. The base fee is $30 per month, which includes up to 150 minutes of long distance. The cost for all minutes over 150 each month is 15 cents per minute. With this plan, how much will it cost Alexandria to talk for 230 minutes, right? So let's consider the function first. We'll write the cost with the time. So cost is a function of time here. Initially, there is a flat fee, which is $30. And this is valid if the time is from 0 to 150 minutes, correct? However, for additional minutes, any minute over 150, 15 cents are charged. It means that 0.15 times time taken above 150 means t minus 150. That will be charged additionally 15 cents per minute, right? And of course, for the first 150 minutes, you have to pay $30. So that becomes your criteria for the cost when t is greater than 150 minutes. Is that clear? Now the question here is, with this plan, how much will it cost Alexandria to take 230 minutes? So we can substitute 230. So cost for 230 minutes will be how much? Will be 0.15 times 230 minus 150 plus 30, correct? Which is 0.15 times, so take away 150 from 230, so 13 take away 5 is 8, so we get 80 plus 30. Now we can multiply this, we get 8 times 5 is 40, 0, 8 times 1 is 8 and 4 is 12, so we get 12.0, right? This one of the decimal goes away with that 0 plus 30. So the cost will be $42, right? So we get our answer, which is $42. Is that clear to you? So that is how we can calculate the cost as asked in this question. 2 more questions to go. We have 10 questions in all. Here is question number 9. Anil and Ben buy food for a fundraiser. One case of 24 hamburgers cost $36. One case of 12 drinks cost $9. How much will food for 60 meals cost if each meal is made up of 1 hamburger and 1 drink? You can pause the video and answer this question. Well, we need 60 meals, right? However, you can only buy in the cases. Correct? Now to get 60, how many cases of hamburgers you need, right? So first you need cases of hamburgers. So we need 60. Each case has 24. If I divide 60 by 24, in that case it is 2 point something, correct? So that basically implies that I have to buy 3 cases. So if I buy only 2, I get only 48. I cannot serve 60 people, so I have to buy 3 cases. You get the idea, right? So now let's find cases of drinks. Now in this case, we have 12 drinks, right? So 60 meals, each has 12 drinks. So that goes evenly by 5. So we could have 5 cases of drinks. That is fine. So now the total cost will be how much? Total cost is 3 cases of hamburger, which is each case is 36. So 3 times 36 plus 5 cases of the drinks, so which is 5 times 9. 9 is the cost, correct? So we can add this up and get our result. So 3 times 6 is 18, 8, 1, this is 108 plus 9 times 5 is 45. So let's add this. 5 and 8 is 13. 1, 5, 153. So our answer is $153. Is it clear? So that is how we are going to answer this. So remember, you have to buy in full cases. You may have some extra hamburgers, that's fine. But you cannot buy 2.5. That's the whole idea, right? Okay. The last question here is, write three fractions between 4 and 7. So the question here is, we have fractions 4 over 7 and we have fraction 5 over 7. I want you to write three fractions here in between them. You can actually pause the video and try and answer this. Well, here is a cool method of doing it. Now there is no number between 4 and 5. We normally don't write decimal numbers in the numerator, right? Since we need to write three fractions, what we can do here is that we can multiply both by 3, numerator and denominator, and write equivalent fractions. Right? So if I do that, I get here 12 over 21 and 15 over 21. Now we have two fractions. Do you see that? Well, so when you multiply by 3, you only get two fractions, 13 and 14. So next number we should have taken, which is multiply by 4. Okay, so since we need three fractions, I have to multiply not by 3 but by 4, right? So we'll times it by 4, both of them. So when you do with 4, you get 4 times 4 is 16 over 4 times 7 is 28, right? On this side, 4 times 5 is 20, and here you get 4 times 7 is 28. So now we have more fractions in between, and we can write this as 17 over 28, 18 over 28, and 19 over 28. So these are the three fractions in between 4 over 7 and 5 over 7. Is that clear to you? So that is a technique of placing infinite fractions in between any two fractions. Does make sense to you? So that is how we could do this. I hope this test paper, where many of the questions have been taken from previous test papers, will definitely help you to prepare for such a test and to understand the basics about arithmetic. Thanks for your time and all the best.